Good morning, hello, and welcome. Are you a student exploring the world of data, or a professional working with information systems, or a business leader aiming to make smarter, data driven decisions? Join me as we dive deep into the world of data management, a topic that not only is vital today but will shape the future of how organizations operate, grow, and innovate. In this session, we will explore the foundation of data management, which is what it is, why it matters, and how it impacts every sector. We'll then look at key strategies and best practices, which includes data governance, data quality, integration, security, etc. Then we will move to the emerging trends and technologies like the AI powered data automation, cloud native architecture, and the shift towards real time analytics and data mesh model. Whether you are just starting out or you are a seasoned expert, this video offers clear explanation, practical insight, and real world relevance, all explained in a simple and structured way. So, hit the play button and let's explore how effective data management can transform decisions, improve trust, and future proof organizations in the digital age. This is your host, Savit Vittal Salian. Welcome. Namaskar. See you in the video. As part of this video, we will be starting off with an introduction, followed by definition and importance. Then we look at the core components of data management. We'll go through the life cycle. We look at technologies and the tools that's currently available. Key sectors. We look at regulatory compliances and data privacy aspects of data management. Look at challenges. We look at some of the best practices currently in play. We'll then go into the role play by AI and automation. Look at emerging trends, followed by a few case studies. Then we'll touch base on SOX, PCI DSS, and Basel III from data management perspective. We look at penalties for poor data management. Then we look at products in the industry which supports data management. And then finally we will have our conclusions. In today's digital economy, data has become the new oil, essential, valuable, and central to decision making and innovation. Every organization, regardless of its size or sector, generates and processes massive volume of data from various sources, including customer interactions, business transactions, sensors, and social media. Managing this data effectively is crucial to extract insight, maintain regulatory compliance, protect privacy, and gain a competitive advantage. This video explores the vast domain of data management, detailing its components, significance, challenges, and the emerging trends shaping its future. Data management refers to the practice, architectural techniques, and tools used to collect, store, secure, and use data effectively. It ensures that data is accurate, available, and accessible for decision making. With data becoming the backbone of digital transformation, robust data management enables the organization to improve decision making through analytics and business intelligence, ensures data accuracy, consistency, and security. It helps maintain regulatory compliances. It helps to optimize operational efficiency. It helps enhances customer experience, and it supports innovation and new business models. In essence, data management forms the foundation of information systems and enterprise governance in a data driven world. In simple terms, imagine you own a grocery store. Every day you collect information about your product, customers, sales, suppliers, and deliveries. Over time, this information grows into a big pile of facts. If you don't keep it organized, you won't know what is in stock, who bought what, which supplier delivered late, how much profit did you make last month. That's where data management comes in. Data management is like keeping your store files and records neat, safe, and useful. It helps you to collect the right data, store it in the right place, find it when you need it, keep it safe, clean it up, follow the rules. Example, when we say collect the right data, these are like customer names, sales numbers, or delivery date. When you say store it in the right place, it means like keeping in a shelf or a file or a database on a computer. Find it when you need it, it's using for search tools or reports. Keeping it safe so that nobody can steal or change your data without permission. Cleaning up means removing the mistakes, duplicates, or outdated information. Follow the rules. It's like not keeping customer information longer than necessary. Why is data management important? It helps business make better decisions like what to sell or whom to target. It saves time and money by avoiding confusion and mistakes. It keeps customer data safe and private, which builds trust. It makes sure you follow the law, like not misusing personal data. In a simple analogy, let's take your kitchen. Think of your data like the ingredients in your kitchen. Good data management is labeling and dating each container. This is data classification. Putting things in the right place. This is data storage. Cleaning out old leftovers. This is data deletion. Locking up dangerous items. This is data security. Knowing where to find things fast. This is data retrieval. A well managed kitchen is equal to easy cooking. A well managed data system is smart business. Hope this analogy helps you understand this space better. In summary, data management means organizing and protecting your information so that it's useful, trustworthy, and safe. Just like organizing your home or business records properly. Let's now look at the core components of data management in detail. Data governance. Data governance encompasses the framework, policy, roles, and responsibilities, ensuring data accountability, quality, and security across the organization. It aligns data initiatives with business strategies and facilitates compliance with regulatory requirements. The key elements in data governance is data ownership and stewardship, policies and standards, data lineage and classification, governance council and committees. In simple terms, imagine you are managing a shared family kitchen. Everyone in the house uses it. But unless there are clear rules, things will go wrong. Like someone putting milk in the freezer, no one cleans up the mess, or the same ingredients are bought twice, and nobody knows when things have expired. That's where governance comes in. Data governance is like setting the rules, roles, and responsibilities for how data is used, stored, cleaned, and protected in a company, just like setting kitchen rules at home. So, what does data governance do? It makes sure that everyone in an organization handles data responsibly by setting rules about what kind of data can be collected and how it should be used. By assigning roles like who owns the data, who can change it, and who can access it. Data governance helps ensure data quality so that information is accurate, complete, and not duplicated. It helps in protecting data privacy and security so only the right people can see or use the sensitive data. It helps in making sure the organizations are following the law, like data privacy regulations, etc. Now, why is data governance important? It prevents confusion. Everyone knows what data means and how to use it. It helps reduce the risk, that is, ensuring there are less mistakes, leaks, or fines from breaking rules. It helps improve trust in your data, in your business decision, and in your customer. It helps save time and effort. This is by avoiding data chaos and duplication. A simple analogy in this case we can take as library rules. Think of data as books in a public library. Data governance is like defining how books are catalogued and shelved, deciding who can borrow, return, or move the books, making sure books are in good condition and in the right section, keeping records of borrowed books, or following rules so books aren't lost or misused. Hence, without governance, the library becomes a mess. With it, everyone benefits. So, this is how data governance work. In summary, data governance is about setting up rules and responsibilities so everyone uses data properly, safely, and in a way that keeps it trustworthy. Just like managing a shared space with care and accountability. Data architecture. Data architecture defines the blueprint for data management, which includes data model, storage solution, data flows, and integration mechanism. It ensures scalable, secure, and efficient data processing. The focus area includes logical and physical data models, data flow diagrams, cloud and hybrid architecture, API and microservice architecture. In simple terms, think of data architecture like the blueprint of a house. Before building a house, you would need a plan that shows where the rooms go, how are the plumbing and electricity connected, where are the doors and windows placed. Without a good plan, the house may be hard to use, unsafe, or impossible to maintain. In the same way, data architecture is the plan for how data is collected, stored, connected, and accessed in an organization. What does data architecture do? It helps company organize its data system by answering questions like where should we store our data? Example, whether in cloud servers, database, or local system. Or how do different systems talk to each other, like linking sales data with customer information. Who can access which data? Example, ensuring HR data is private but sales data is shared. How does data flow from one place to another? Example, when a customer places an order, how it updates the inventory. What format should data be in? Example, date format, product codes, or customer names. This is what data architecture will do. In simple analogy, example is take city planning. Imagine a city, roads, water pipes, power lines, buildings, etc. Here, buildings is application. Roads are data pipelines. Power grids are network infrastructure. City map is data architecture. Without a city plan, everything would be chaotic. Similarly, without data architecture, a company's data would be messy, disconnected, and hard to use. Why is data architecture important? It helps make faster decision by connecting the right data. It saves money and time by reducing confusion and duplication. It makes data secure and organized. It supports growth by ensuring systems can scale smoothly. In summary, data architecture is the master plan that shows how an organization's data is organized, stored, and connected, just like the blueprint of a building or the layout of a city. Data modeling. Data modeling creates conceptual, logical, and physical models to structure data for optimal use. It supports application development, data integration, and reporting. There are three types of model: entity relationship model, dimensional model, and NoSQL data model. As an example, imagine you are setting up a grocery store. Before you bring in shelves, cash register, or stock the items, you create a plan. Example, which item go in which aisle? What categories are needed? Example, fruits, dairy, snacks, etc. How do you organize prices, barcodes, suppliers? This planning is just like data modeling and design. It's about deciding how the information, which is the data, should be organized so it's easy to understand, use, and manage. So, what is data modeling? Data modeling is a process of creating a visual map or blueprint that shows what kind of data is stored, like name, age, price, product, or how different pieces of data relates to each other. Example, a customer places an order for a product. Here, the customer, the order, and the product, these are relations. It's like drawing a chart to explain how everything connects. Example, in a school system, a model might show student, his enrollment number, and which course. A teacher, what is the subject that they teach and what are the courses they are conducting. A course will have what type of subjects or subtopics and how would be the grading. So this is a model. And what is design? What is data design? Data design takes the model and turns it into a usable structure for the computer systems or database. It decides what the table will look like in a database, what format the data should be in, whether it's a text, a number, or a date, how to avoid repetition or confusion. It's like building the actual shelf and labels in your store based on the store layout you have drawn earlier. You remember the modeling aspect. Simple analogy, let's take a Lego set. A Lego set or bricks, it thinks like it's a data. So data as a Lego brick. Data modeling is drawing the instruction manual, what goes where. Data design is building the actual Lego structure based on the manual. Without a model, your Lego set will be a mess. With a good model, it is easy to build and fix. So, why is data modeling and design important? Well, it helps developer build database and systems that are organized and efficient. It makes it easier to find, update, or analyze the data. It helps avoid mistakes like duplicate record or missing information. It helps save time when scaling or changing business processes. It helps support data quality and integrity over the long run. Hence, in summary, data modeling and design is like planning and building an organization system for your information. So it's easy to store, use, and connect everything properly, just like designing a well organized store or a workspace. Data storage. Data storage includes technologies and infrastructure used to store structured, semi structured, and unstructured data. It encompasses on premise database, cloud storage, and data lakes. The storage options are four: relational database like Oracle, SQL Server, non-SQL database, example MongoDB, Cassandra, cloud storage, which is AWS or Azure, and data warehouse, example Snowflakes. In simple terms, imagine you have important documents at home like bills, school certificates, family photo, recipes, and receipts. You need a safe place to keep them, right? Some go in filing cabinets, others in photo album, maybe some of will be under the box in your bed, under your bed, that's storage. You're putting things in place where you can find and use them later. Now imagine those documents are digital, like email, photos, videos, bank records, and customer lists. That's where data storage comes in. So, what is data storage in simple terms? Data storage is where your digital information is kept safely so it can be used when needed. Just like storing paper in folder or kitchen items in a cabinet, computer stores data in places like hard drive, cloud storage, USB drives, or memory card. So why is data storage important? It's important so that to keep information safe and secure, so you can organize data and find it easily later, so that you can reuse or update information when needed, and also to protect important data from getting lost or damaged. So in a summary, a local storage is a file cabinet at home. An analogy here, the equivalent is hard drive, USB sticks. A cloud storage is a rental locker you can reach from anywhere. Example in analogy would be the Google Drive, Dropbox, OneDrive. Backup storage is a safety copy you keep in just in case. It's an external hard drive or a cloud backup. Example. Cold storage, this is archival documents you rarely use. Example, long-term backups and tapes. In simple analogy, think data like your clothes. Some you wear daily, so you keep them in your closet, so it's fast, nearby storage. Some are for special occasion, you keep them in boxes, archived. Example. Some old ones you might donate later. You store them in attic. This is long-term storage. And you want them all, from ensuring that it is safe from any damage. They are organized by types and easy to access when needed. That's exactly how we treat digital data too. Now, in summary, data storage is the way we keep digital information safe, organized, and ready to use. Just like storing important things in drawers, cabinets, or the cloud. Data security. Protecting data from unauthorized access, breaches, and misuse is a critical component of data management. Security practices include encryptions, which is at rest and also in transit, access control and identity management, auditing and logging, data masking and anonymization. In Simple language, imagine your personal diary, phone, or wallet. You don't want anyone reading your private notes, seeing your messages, or taking your money. So, what do? You lock it up, you keep it safe, you choose who can access it. That's exactly what data security is. But for digital information. What is data security in simple terms? Another way of looking at it. Data security means protecting your digital information like names, password, bank details, photos, company records from hackers accidentally sharing, unauthorized access, from loss or damage. It's about keeping data safe, private, and only in the right hands. So, how do we secure the data? Well, we secure it through passwords, encryption, backups, firewall, using antivirus, using access control, using two factor authentication. Why? Well, passwords is like using keys to open your front door. Encryption, like turning your message into a secret code. Backups, like making a copy of your photo in case your phones break. Firewall and antivirus, like security guard or a lock on your gate. Access control, like giving only family members the house keys. Two factor authentication, like using a key and a fingerprint to open a vault. So, why is data security important? Well, to protect privacy, like your medical records or phone messages, to avoid fraud or theft, like stolen credit card numbers, to comply with the laws, GDPR, CCPA, etc., to build trust with customers and employees, and to keep system running smoothly without disruption. In simple analogy, it's about protecting your home. Think of data like your valuables belonging inside your house. You lock your door, that's your password. Example. Second analogy, you install an alarm, which is like security monitoring. You make copies of important paper, that's your backup. You do not let strangers in, which is a type of access control. Data security does the same, but it's done on the computer systems, phones, and cloud accounts. Hope this helps with understanding. Hence, in summary, data security means keeping your digital information safe from theft, loss, or misuse. Just like locking your door, setting alarms, and guarding your valuables. Data integration. Data integration ensures that data from multiple sources are combined to provide a unified view. Do note, multiple sources are combined to provide a single view or unified view. That is data integration. In this, ETL and ELT processes are commonly used. ETL is extract, transform, load. The integration methods, there are four. The first is ETL ELT pipeline. Second is APIs and connectors. Third is data virtualization. And the fourth is enterprise service bus. In simple language, what is data integration? Imagine you are planning a wedding. You have information in different places. The guest list is in a notebook. The budget is in a spreadsheet. Menu is in an email. And the music playlist is on your phone. Wouldn't it be easier if all of this information was in one place? That's what data integration does. It brings different data from different places together. So everything is organized and connected in one system. So what does data integration mean in simple terms? Data integration is the process of combining information from different places like apps, systems, or department into a single unified view so it's easier to use and analyze. Example, a company may have customer data in CRM system, sales data in an Excel sheet, support tickets in a chat tool, website visits in Google Analytics. Data integration brings all of that together so the company sees the full picture of each customer. Now, why is data integration important? Well, first, it saves time, so no need to switch between systems. It helps improve decision making because you see all the information in one view. It helps with reporting. Using a unified data, you have a clear insight. It reduces error because there is less manual copying pasting of the data, and you are making the system talk to each other. They are not in silos. The other analogy is stitching a quilt. Think of data like different pieces of a fabric, each from different place. Data integration is like stitching those pieces together to make one beautiful quilt. You get a complete, useful, and a connected results. Hope these examples bring in clarity. So, how does it work? Extract, it's pull the data from different source, whether it's app, database, files. Transform, which is clean it up and make the format matches. You need a single format so that you can bring it together. The next is load, it's bringing it to one central place like data warehouse or dashboards. Do note, unless you transform, you cannot bring it together. Unless you extract, you cannot transform. So remember the ETL. Data quality. Data is considered high quality when it is complete, accurate, timely, and consistent. Data quality management includes monitoring, cleansing, and enrichment process. The key dimensions include accuracy, completeness, consistency, uniqueness, and timeliness. In simple terms, imagine you are baking a cake and the recipe says use 2 cups of sugar, bake for 30 minutes, add eggs and milk. Now imagine one recipe says sugar but doesn't say how much. Another says bake for 300 minutes. Now that's a disaster. Another says use flour but you find sand in the bag. Would your cake come out right? Probably not. That's why quality matters. And it's the same with data. Data quality means your information is correct, complete, up to date, consistent, clear, and understandable. Just like good ingredients make a great cake, good data makes good decision. Why does data quality matter? Because bad data is equal to bad result. That's how straightforward it is. If a company has a wrong phone number, what happens? It can't reach the customer. If it has missing delivery address, the package will never arrive. Outdated pricing, you possibly overcharge or incur loss. If you have duplicate record, it's confusing and a lot of effort would be wasted. Then the decisions, service, and customer experience will all suffer. What makes data a good quality data? It's accuracy, completeness, consistency, timeliness, uniqueness, and validity. Accuracy here is the data correct? Is the phone number correct? As an example. Completeness, is there anything missing? Consistency is the data the same across the system? Timeliness is it up to date? Uniqueness, is it duplicated? Which is primarily the same customer listed twice. Validity, does it follow the right format? So that is what makes data a good quality data. Another analogy, let's take grocery labels. Imagine buying a milk and you find there is no expiry date. Is it safe? No, potentially unsafe. Two labels with different brands. What happens? We don't know which one is real. Wrong barcode. You're possibly charged more, or worse, charged less. You lose. Just like labels must be clear and reliable, so must be your data. In simple terms, data quality means having a clean, correct, and complete information so that you can trust it, use it, and make smart decisions, just like using fresh ingredients for a recipe. Metadata management. Metadata describes data providing context and improving data discovery and governance. It is essential for data cataloging, lineage tracking, and compliance audit. There are three types of metadata: business metadata, technical metadata, and operational metadata. Let's revisit what's metadata and what is metadata management. Let's start with the word metadata. Metadata simply means data about the data. Imagine you have a photo on your phone. The photo itself is the data, but it also shows you when it was taken, where it was taken, which phone or camera was used, and who is in it if it is tagged. All of that is metadata. It tells you more about the photo without changing the photo itself. Now imagine your organization has thousands of such files, reports, documents, and database. So how do you know what each one contains? How do you find the right one? How do you track how it was created? How do you find it out? Or how it was changed or when? That's where metadata management comes in. So, in simple terms, metadata management means organizing, storing, and using the labels and the descriptions of your data so that it's easier to find, understand, trust, and use. It is like putting helpful tags, notes, and instructions on everything so people don't waste time guessing or searching blindly. So, why is it important? Well, find data faster, like a search engine for your data. Understand what data means. Example, is the date of birth or date of booking is correct? Track changes, that is, who changed what and when. Ensure data quality and compliance. Look at example the personal tag, example relevant for GDPR. Control access, that is flagging which data is sensitive, etc. The other analogy would be library catalogs. Think of a big library. The books are your data. The catalog system are your metadata, which includes your title, author, subject, location, etc. Metadata management is how the library keeps that catalog updated, organized, and searchable so you can find the right books in seconds. Without metadata management, you will be lost in a sea of books or files. Think through about it. From a summary perspective, we have business metadata. Example, customer name. Purpose helps everyone to understand what data means. Technical metadata, the file format, size, table name, data type, etc. It helps IT manage the system. That's the purpose. Operational metadata, who created the file, when was it updated, Purpose helps to track usage and changes. In summary, metadata management is about organizing the data about your data, like labels, tags, and notes. So everyone can easily find, understand, and use the right information at the right time. Master data management. MDM ensures a single, accurate, and authoritative source of truth for key business entities such as customers, products, suppliers, and employees. There are three components for MDM: data matching and deduplications, hierarchy management, and data stewardship workflow. Let's understand MDM with an analogy. Imagine you're running a family business with several stores. Each store keeps its own customer list, product details, supplier contacts. But here is the problem: one store spells a customer name as John and another uses another word for the same customer or a different name. A product is priced 500 in one and 550 in the other. One store has a supplier's old phone number and the next one has a new one. Now there's confusion, duplication, and mistakes. That's where master data management or MDM comes in. Master data management is the process of creating one clean, correct, and consistent version of your most important data, like the customer name, product info, employee records, and supplier details, and shares it across all your systems and department. It's like saying, let's clean up the mess and agree on the truth. So what does the master data include? Master data is the core information every business needs to function properly. Example, the customer, the product, the employee detail, the supplier details, and the accounts. Why is it important? It helps avoid duplicates and errors. It helps ensures accurate reporting and analytics. It keeps inventory and billing correct and consistent. It helps improve the customer experience, and it support compliance and audit trails. Without MDM, you might send two bills to the same person, stock the wrong products, or make decisions using incorrect information. Another analogy, let's take one family phone book. Imagine every family member keeps their own list of phone numbers. One says mom is equal to some number, another says mum, and third says mother. Now that's a mess. Now imagine making one shared, accurate phone book and everyone uses it. Everyone updates it. So there are no duplicates, no mistakes. This is master data management in action. So how does it work? In simple language, it collects the data from different sources, whether it is apps, spreadsheets, or systems. It then cleans it, that is, removes the duplicate, fixes typos. Third, links it. It connects related records. Fourth, it stores the single source of truth at a central place. Fifth, shares it across this system. That's MDM. In summary, master data management means creating one clean, trusted version of your most important data, so your whole organization can run smoothly without confusion or duplication. Data warehousing and business intelligence. Data warehouses stores consolidated data for analytical processing and reporting. Business intelligence tools help visualize and interpret the data to support strategic decisions. Some of the popular business intelligence platforms are Tableau, Power BI, QuickSense, Lookers, etc. In simple terms, let's say you own a chain of grocery stores. Each store has its own daily sales, customer feedback, inventory update, employee records, etc. Now imagine you want to answer questions like what's the best selling product across all the stores? Which store is making money or losing money? How much stock do we have in total across the chain? To answer this, you need to gather all your data in one place to analyze and analyze it smartly. That's where data warehousing and business intelligence comes in. So, what's data warehouse? A data warehouse is like a giant digital storage room that collects and stores all your business data from different places, which includes your sales system, customer database, HR softwares, websites, etc. But unlike messy storage, a warehouse is organized, cleaned, ready for analysis. It's designed for looking at the big picture and not for running daily operations. Coming on to BI. So, what is business intelligence? Business intelligence or BI is the process of analyzing the data in your warehouse to discover trends, make decisions, create reports and dashboards, improve performances. Think of it like putting smart glasses on your data. Now you can see what's happening in your business and why. Another analogy would be supermarket and the manager's office. Data warehouse is equal to the back office where all the receipts, stock list and customer comments are collected and organized. And business intelligence is equal to the manager studying those files to make better decisions like which item to discount or when to hire more staff. What can you do with BI? Well, you can see sales trends over the time, understand customer behavior, identify where you are losing money or making money, compare performance by location or time, make smarter decisions based on real facts. Why are data warehousing and BI important? Well, it brings all your data together in one place, helps making decision faster and smarter, helps spot problems early on, helps in improving efficiency and planning, supports your long-term strategy. Isn't that great? Hence, in summary, data warehousing stores all your business data in one organized place, and business intelligence helps you analyze it to make better and faster decisions, like having a super smart dashboard for your company. Data management lifecycle. The data lifecycle includes the stages through which a data flows from creation to deletion. It includes data creation, wherein data is generated through various sources. Data collection is a process wherein data is acquired, ingested into the system. Data processing is about transforming the data, cleaning it, and organizing it. Data storage. Here, data is securely stored in database or data lakes. Data use. Data is used for operation, analysis, or reporting. Data sharing. This is data is shared internally or with external partners. Data archiving. It's the old data are archived for legal or historical reasons. And then we have data destruction. This is where data are securely deleted when they are no longer needed. Let's pause and go through the cycle again in a simple format. Think of data like a product, just like milk in a grocery store. From the moment it's made to when it is delivered, used, and finally thrown away, it goes through a life cycle. The data management life cycle is a journey data goes through from the moment it's created to the time it's no longer needed and is deleted. From a stage perspective, the first was data creation. That's when the data is born. This is when data is first generated, like filling out a form, clicking on website, making a sales, or taking a photo. Example, a customer orders a pizza, his name, phone number, and order details are created as data. That's data creation. Data collection. Data is gathered from different sources: app, devices, website, forms, emails, etc. Example, the pizza shop collects data from online orders, phone calls, and delivery apps. That's data collection. Data storage. Once collected, the data is stored in a database or a cloud storage or a files. Example, all orders are stored in pizza shop's computer system or cloud servers. Next is data usage. Data in this is used to run the business, analyze trends, or improve the service. Example, the pizza shop looks at data to find the best selling toppings or the busiest delivery time. Data sharing. Sometimes data is shared internally, that is between departments, or externally with partners or apps. Example, the shop shares delivery address data with drivers or third party delivery apps. Data archiving. It's when data is no longer used every day but needs to be kept for legal, historical, or backup reasons. It's archived. Example, last year orders are moved to long term storage but kept just in case. Data deletion or destruction. This is when the data is no longer needed. It should be securely deleted to protect privacy and follow the required laws. Example, customer data after 5 years is deleted to comply with privacy rules in some regions and locations. Why does it matter? Why do you have this life cycle in the first place? Well, it helps in understanding and managing the life cycle. It helps in better decision making for quality data, data privacy and security, compliance with the law, saving money by not storing unnecessary data, cleaner and more useful systems. Hence, in summary, the data management life cycle is the step by step journey the data is taking from being created and used to being safely stored and finally deleted. Just like any product we use and eventually retire. Let's now look at the tools and technologies in data management space. Modern data management is driven by a broad ecosystem of tools under various categories. Example, the database management system has MySQL, PostgreSQL, Oracle, Microsoft SQL servers, etc. Data Lake has Hadoop, Amazon, Azure. ETL tools have Informatica, Talent, Apache. Data quality tools are Selenium, IBM, Infosphere, Actacama. Metadata tools are Colibra, Alation. Cloud platforms include AWS, Google Cloud, Microsoft Azure. Big data technologies include Apache Spark, Kafka, Hive, Flink. Well, this is a snapshot. There are more in the list and new tools keep coming in with enhancements. You can take this as a reference and you can pick and choose. You can test them, the one which works for you and suit. Data management in key sectors. Let's take few. The first is the banking, financial services, and insurance sector. The BFSI relies on data for fraud detection, risk modeling, regulatory compliances, and consumer analytics. Data lineage, security, and audit trails are critical in this space. From healthcare perspective, it's used in patient records, diagnostic data, clinical research. They require secure, accurate, and interoperable data systems. HIPAA and HL7 standards governs healthcare data management. In telecommunication, call data, network logs, customer profile support, network automation, churn prediction, and billing. Real-time analytics and data integration are the key enablers. In government, you have e-governance, census data, public record, and smart city initiative rely on large-scale data integration, privacy, and transparency framework. With increasing regulatory scrutiny, data management must support compliance with global and local laws. Some of them being the GDPR, which requires consent, data portability, and right to be forgotten. The CCPA is about data transparency and consumer rights. HIPAA, protection of health information. The PDPA, localized personal data protection. The SOX, PCI DSS, Basel III for financial and operational compliance. Compliance requires robust data classification, encryption, access logs, and governance processes. Let's go deeper. Example for GDPR. The GDPR enforced since May of 2018 is the European Union's cornerstone legislation on data privacy and protection. It governs how organizations collect, process, stores, and manages personal data for EU citizens. The implications for data management is first, under data inventory and classification, organization must maintain detailed records of what personal data they collect, why and how it is used. Data must be classified based on sensitivity and usage. From a data governance and ownership perspective, clear data stewardship and accountability are required for personal data handling. Designation of data protection officer for oversight is mandatory in many cases. From consent and transparency perspective, data collection must be lawful, transparent, and with explicit consent. Privacy notices and consent mechanism must be clear and understandable. From a data subject rights perspective, data subjects have the access to right to access, rectify, erase, or right to be forgotten and port their data. Data management system must support these rights efficiently. From a data minimization and retention perspective, only data that is necessary for the purpose should be collected. Personal data should not be retained longer than necessary. From security and protection perspective, personal data must be protected through technical and organizational measures related to encryption, access control, etc. Breaches are expected to be reported within 72 hours. From a data processing and third-party management perspective, clear contracts and controls are required with processors and third-party vendors. Organization must ensure end-to-end data protection across their data supply chain. From a data lifecycle management perspective, GDPR enforces complete lifecycle visibility from data creation to deletion. Emphasis on privacy by design and privacy by default. In conclusion, from a data management perspective, GDPR drives greater accountability, transparency, and control over personal data. It necessitates robust data governance framework, security mechanism, and compliance monitoring tools across the data lifecycle to ensure lawful and ethical data use. Let's now look at the CCPA. The California Consumer Privacy Act or CCPA effective from 2020 January, is a comprehensive data privacy law that enhances privacy rights and consumer protection for the resident of California. It imposes significant responsibilities on how organizations manage personal data. The key implications for data management here is personal data inventory and classification category. Organization must identify and document what personal information is collected, its source, purpose, and sharing practices. Data must be tagged and classified to support rights and compliance reporting. From consumer rights support perspective, system must support the following data subjects rights. Right to know what data is collected and why, right to delete personal information, right to opt out of the sales of personal data, right to non-discrimination for exercising privacy rights. From a consent and data transparency perspective, clear privacy notice and do not sell my personal information options are required. Data management practice must ensure transparent collection and use policy. From a third party data sharing control perspective, detailed record keeping and contractual controls with third party data processors are required. Ability to track and control data flow across partners and vendors are expected. From a data access and response mechanism perspective, organizations must implement efficient mechanism to receive, verify, and fulfill consumer data requests within defined timelines. From a security and data governance perspective, CCPA emphasizes reasonable security practice to protect personal data. It encourages the development of internal governance policy and data minimization principles. From a data retention and lifecycle perspective, organizations must determine and document data retention schedules. Data should be securely deleted when no longer required, especially upon consumer request. From a data mapping and reporting perspective, data management tools should enable data mapping, audit trails, and reporting capabilities to demonstrate compliance. In conclusion, from a data management perspective, CCPA demands a transparent, responsive, and secure approach to handling personal data. It requires organizations to know their data, secure it, classify it properly, and enable user centric controls, thereby embedding privacy into everyday's data operations. From PDPA perspective, the Personal Data Protection Act in both Singapore and India establishes comprehensive framework to regulate the collection, use, storage and disclosure of personal data. While each country legislation differs in scope and structure, both emphasizes transparency, accountability and data security. In specific, from a key data management implication perspective, under consent and purpose limitation, organization must obtain informed consent for data collection and processing. Data must be used only for explicit and legitimate purpose. From a data governance perspective, appointment of data protection officer is mandatory. Implementation of policies, processes, and training to ensure data accountability is required. It's a mandatory thing. From a data retention and disposal perspective, data should only be retained as long as necessary and must be disposed of securely when no longer needed. From an access and correction rights perspective, individuals have the rights to access and correct their personal data. Data systems must support identity verification and data retrieval. From a data breach notification perspective, mandatory reporting of data breaches within 3 calendar days if there is a significant harm or impact. From protection and security perspective, organizations must ensure reasonable security arrangements to prevent unauthorized access or disclosure. From TPDPA perspective, which is the Digital Personal Data Protection Act of India, consent based processing includes consent must be free, informed, specific, and unambiguous. And notices must accompany all consent requests. From a data fiduciary responsibility perspective, organizations must maintain data accuracy, integrity, and confidentiality. They must provide mechanism for grievance redressal and data access. From a data minimization and purpose limitation perspective, only data necessary for the stated purpose must be collected and retained. From user rights management perspective, data principals have right to access for correction, erasure, and grievance redressal. Data systems must support digital portals for exercising these rights. From a data security and breach response perspective, obligations to implement security safeguards and report breach to the Data Protection Board of India. From a cross border data flow perspective, subject to whitelisting by government, data export must ensure equivalent protection. In conclusion, from a data management perspective, PDPA in both Singapore and India emphasizes strong data governance and accountability, transparent consent mechanism, lifecycle management of personal data, which is right from collection to secure deletion, security controls and user centric rights enablement. Organization must invest in structured data management system, implement data protection policies, and ensure compliance through auditability and automation. Pausing here, I would request students and organizations who have businesses dealing in Singapore and India to go through this to be sure you are in line with the expectations of PDPA, because a breach here can cause a lot of penalties and censures. Let's now look at SOX, PCI DSS, and Basel III from data management perspective. SOX. The objective is to ensure accuracy, integrity, and accountability of financial reporting in publicly traded companies. The data management implications are: first, from a data integrity and accuracy perspective, financial data must be accurate, complete, and traceable. Systems should ensure that records are not altered or deleted improperly. From an access controls perspective, implement role based access to financial systems and ensure that only authorized personnel can modify sensitive data. From audit trail perspective, all data interaction is required to be logged and traceable to support internal and external audits. From a data retention perspective, financial data must be retained for at least 7 years, requiring robust archival and retrieval mechanism. From an IT control documentation perspective, key financial systems must undergo control testing and documentation, ensuring data systems are reliable and tamper resistant. From a PCI DSS perspective, Their primary objective is to protect card holders' data and ensure secure processing, storage, and transmission of payment information. The key implications are from a data encryption and tokenization perspective, card holders' data must be encrypted both in transit and at rest. Use of tokenization is encouraged to reduce risk. From an access restriction and monitoring perspective, access to payment data must be strictly limited based on need to know basis only, and all access must be monitored and logged. From a data minimization perspective, only necessary data should be stored. Sensitive data such as CVV should not be retained post authorization. From a secure storage practice perspective, storage of cardholders' data must follow layered security measures. From an audit logs and retention perspective, maintaining audit trails of data activity and ensuring survey logs management for forensic and compliance validation is mandatory. From a Basel III perspective, the objective is to strengthen regulations, supervision, and risk management in banking sector by improving the capital adequacy, stress testing, and liquidity. The implications are few, namely from a risk data aggregation and reporting perspective, banks must implement robust systems to aggregate risk data across entities, enabling timely and accurate reporting. From a data quality and consistency perspective, it requires high data accuracy, timeliness, and completeness for the capital and liquidity calculation. From a data lineage and governance perspective, risk related data must be traceable from source to report with documented governance and ownership. From a regulatory reporting automation perspective, regulatory data submissions must be automated, auditable, and standardized across systems and jurisdiction. From real-time capability perspective, bank should develop real-time or near real-time capabilities to assess liquidity and credit exposure during stress events. In conclusion, the focus for SOX is financial reporting integrity. From a data management perspective, it's audit trails, data retention, and access control. From a PCI DSS perspective, their focus is payment data security. From a data management perspective, it's about encryption, minimization, and monitoring. From a Basel III perspective, their key focus is banking risk and capital adequacy. From a data management perspective, it is risk data quality, aggregation, and reporting. Hence, from a data management perspective, all three emphasize the need for secure, accurate, and auditable data systems that align with regulatory expectations, implementing strong governance, lifecycle management, and real-time visibility is essential to maintain compliance. Let's look at challenges in data management space. Despite advancement, organizations face several challenges. Some of them are as shown, which are data silos, data volume and variety, which is primarily explosion of unstructured data, quality issues, security and privacy risks, lack of skilled resources, legacy system, and cost and complexity. These are some of the major ones. Simply put, managing data today is like trying to organize a huge, growing library where new books keep arriving every second. Some are in different languages, some have wrong or missing pages, and you are not even sure who's allowed to read which books. That's what organization face when managing large amount of digital data. Let's try to break it down. Too much data. The challenge here is there is just too much of data coming from everywhere. Email, website, apps, sensors, customer. It's like trying to organize 10,000 new boxes every day with no labels. Just imagine. That's overload. Next is bad or dirty data, if you put it that way. Challenge is data often has mistakes like misplaced names, wrong phone numbers, or missing fields. It's like trying to cook using spoiled ingredients. The result will never be right. On silos, it's about data stored in silos. The challenge is data are currently stored in different places, departments, or tools that don't talk to each other. It's like each team in a company locking their files in a separate cabinet and no one can see the full picture. From a security and privacy issue perspective, the challenge is keeping data safe from hackers and making sure only the right people can see it. It's a major challenge. It's like having valuable jewelry but no locks on the door. From a skill perspective, we don't have enough skilled people. Managing and analyzing data requires experts, and there is a definite shortage of trained professional in this space. It's like having a big machine but no mechanic to run it. We do have a serious challenge in this. From a legal and compliance rules perspective, it like laws like GDPR, CCPA requires companies to protect personal data and follow strict rules. It's like needing to follow different traffic rules in every city or risk getting fined. It's a pretty complex space and you need to have experts who understand these laws. The other is hard to find the right data. When the data isn't labeled or organized properly, it's hard to know where it is or what it means. It's like trying to find a file in a messy desk with no folder or names. Then we have a challenge of outdated or duplicate data. Old data may stay in the system even when it is no longer useful. And sometimes the same data is stored twice or more. It's like having 10 versions of the same book and not knowing which one is current. The next is cost of storing and managing the data. Big data needs big storage and large computing power, which can be expensive. Maintaining it is a challenge from a cost perspective. It's like renting a warehouse for things you are not even using. In summary, data management is challenging because too much of data, messy data, wrong data, privacy risk, disconnected system, and the cost of keeping it all under control. This is challenging. It's like trying to run a growing library without a librarian, or labels or locks. Let's now look at some of the best practices for effective data management. As listed, it's about establishing a strong governance framework, investing in modern architecture, ensuring data quality through continuous monitoring, automate ETL and data pipeline, train teams on data literacy and tools, implement metadata and lineage tracking, align data strategy with business goals, secure data with role-based access and encryption, ensure regulatory compliance through audits, and foster a data-driven culture. In simple terms, what it means? Well, managing data is like taking good care of important household items. You keep them organized, clean, safe, and easy to use when needed. Here are some everyday practices to manage data effectively. Know what data you have. It means you keep track of type of data you collect, like customer names, phone number, sales record, employee info, or product list. The idea here is you can't manage what you don't know you have. Next is keeping data clean and correct. What it means is fix mistakes like spelling mistakes, removing duplicates, update old or missing information regularly. It like an example, it's like keeping your contact list updated so you don't call the wrong person. The next is storing data in the right place. What it means is using folders, database, or cloud storage that are all well organized and easy to search. Do not store everything in one messy file. It's like mixing clothes, tools, groceries in one drawer. Put it right. Keep it at the right category. Protecting data with security measures. What it means is using strong password, allow access only to trusted people, and make sure sensitive data is encrypted or locked. Like real life example, just like locking your house and keeping your ID safe. Back up your data regularly. Keep a copy of important data in case the original is lost, stolen, or damaged. Analogy, like making a copy of family photo on important document just in case the original gets lost. Limit who can access the data. Give permissions only to those who need the data for their work, not everyone. Why it matters? Just like not giving every house key to everyone you know. A straight analogy. Follow privacy and legal rules. Respect privacy laws like GDPR, CCPA, DPDP Act, etc. Always get permission before collecting or sharing personal information. If you wouldn't want your own info to be shared, don't do it for others. There's a simple logic. Use good tool and technology. Use software that helps you collect, store, analyze, and protect data efficiently, like using a good planner app or budgeting tool to stay organized. Train everyone who handles the data. Make sure everyone, even the non-technical staff, knows how to handle data safely and responsibly. Do note, one small mistake can cause a big problem. Delete what you don't need. Old data you no longer use should be safely deleted to avoid clutters and risk. Think of it like as spring cleaning. Don't keep things that serves no purpose. Hence, in summary, effective data management means knowing what data you have, keeping it clean, safe, and organized, and using it wisely, just like taking care of important things in your home or office. Let's now look at the role of AI and automation in data management. Artificial intelligence is transforming data management in many ways. Few of them are listed. First is automating data cleansing. This is about detecting and correcting the anomalies. Next is data cataloging with NLP, which is actually extracting metadata from content. Next is predictive data quality monitoring, which is anticipating data issues. Next is smart ETL, which is using machine learning for efficient data transformation. Next is anomaly detection. Detection, identifying outliers in data usage patterns. Data discovery and classification, which is all about AI driven content scanning. Hence, AI reduces manual efforts, enhances scalability, and improves decision making. In simple terms, imagine you are running a small office and every day you have to enter customer details, clean up duplicate entries, sort emails and files, make reports from spreadsheets. Now imagine having a super smart assistant who can do all these things automatically, quickly, and without any mistakes. That's what AI and automation do for data management. They they help you handle large amount of data faster, smarter, and with fewer errors. What is AI in simple terms? AI is like teaching computer to think and learn like humans. It can understand patterns, make prediction, and even improve our time without needing constant instruction. And what is automation? Automation means using machines or software to do repetitive tasks automatically. Things you would normally do by hand, like copying data, sending reports, or updating records. So, how does AI and automation help? Well, cleaning data automatically. AI can spot mistakes, duplicates, or missing information in your data and fix them on its own. It's like a robot that finds typo in your contact list and corrects them. Organizing and tagging data. AI can sort and label files, emails, or documents based on what they contain without you having to do it. It's like having a helper who files every document in the right drawer. AI can analyze large volume of data and give you smart insights or suggestion, often in real time. It's like a calculator that not only adds up your expenses but also tells you where you are overspending. AI can learn from past data and help predict future events like customer behavior or product demands. It's like a smart weather app that learns your area pattern and tells you when to carry an umbrella. Automation tools can move data between systems, generate reports, or send reminders without human inputs. It's like setting your coffee machine to start brewing every morning at 7 a.m., but for data. AI can detect unusual activities in data like hacker trying to get in and alert you instantly. It's like a watchdog that barks only when something is wrong and never sleeps. In summary, AI and automation help manage data more efficiently by cleaning, organizing, analyzing, and protecting it, just like having a tireless digital assistant working for you 24 by 7. Let's look at some emerging trends in data management. We have data mesh architecture, which is a decentralized data ownership across domain. Data fabric, which is integrated data management across hybrid environment. Real-time analytics, which is about leveraging streaming data for instant insight. Privacy enhancing computation, which is about secure analytics on encrypted data. Data observability, which is monitoring data health like software systems. Self-service analytics, which is empowering users to access and use the data. Cloud native data platforms, scalable, resilient data services. These innovations are shaping the future of intelligent, agile, and scalable data management. In simple terms, data is growing faster than ever, like a river turning into an ocean. To stay in control, companies are adopting new and smarter ways to manage all this data. Some of the trends are companies are moving their data from on site computers to cloud using services like Google instead of filing cabinets. Why it matters? You can access data from anywhere, anytime, like opening your photo on any devices. That's cloud based data management. Under data fabric, this is a way to connect all data across different system places and formats and make it work together. Think of it as a digital fabric weaving everything together so that data feels like it's on one place even when it is not. AI driven data management. AI is now helping to sort, clean, label, analyze data all automatically. Why it helps? It's less manual work, fewer mistakes, faster decisions. It's like a super smart helper working behind the scene. Self-service analytics. Employee now don't have to wait for an IT team anymore. They can now search and analyze data on their own using easy to use tool. It's like having your own calculator instead of asking someone to do math for you. Data mesh, which is instead of having one central team control all the data, each department manages its own data, like each team being in charge of their own mini database. Why it is useful? It's faster access, more control where it is needed, like every shop in a chain managing its own inventory. Strong focus on data privacy and ethics. With growing concerns about privacy, companies are investing more in protecting personal data and using it ethically. What it means is Clear rules, better consent, and respecting user choices, like locking your diary and not reading someone else without permission. Next is real time data processing. Instead of waiting hours or days, companies want to see live data instantly. It's like getting real time weather or traffic update. Why is it important? Well, for faster decision, quicker alerts, and more responsive services. From a data automation perspective, it's more like a task collecting, updating, and moving data between systems are being automated today. No human hands needed. It's like having a robot helper that works 24 by 7 to keep your files sorted. Hence, in summary, emerging trends in data management are all about using smarter tools like the cloud, AI, and automation to make data easier to access, cleaner, safer, and more useful in real time. Let's look at some case studies. The organization is a multinational consumer goods corporation with a vast portfolio of brands across beauty, health, fabric, and home care. It operates in more than 180 countries and manages vast volume of consumer, operational and market data. The challenge. The corporation faced significant challenges managing data across its global operations. The challenges were data silos across geographies and business units, inconsistent data format and lack of data standardization, time consuming manual reporting, delayed access to real time business insights, and compliance concerns with global data protection regulations. The corporation needed a unified data management strategy that would ensure data consistency, accuracy, and accessibility across all its business units. From a data management strategy and initiative perspective, it established a global data governance office with cross functional teams. It defined clear roles for data owner, data stewards, and data custodian. Implemented data policies, taxonomy standards, and data quality benchmark. This was part of its data governance framework. From data lake and cloud architecture perspective, it migrated data from legacy systems to a centralized data lake on Microsoft Azure. It ensured scalability and faster access to high volume data using cloud native services. It leveraged big data technologies for real time analytics. From an MDM perspective, it implemented MDM to ensure a single source of truth for product, customers, and supplier data. It used automated data deduplication and matching algorithm to enhance data integrity. From a self-service business intelligence perspective, it rolled out Power BI dashboards and real-time analytics tool to over 50,000 employees. It empowered business users with self-service data access, reducing its IT dependency. From a data quality and metadata management perspective, it implemented data profiling tools and data cleansing routines to improve its accuracy. It adapted metadata management tools like Altion for data discovery and lineage tracking. From a regulatory compliance perspective, it built in privacy by design principle to comply with GDPR and CCPA and local data laws. It implemented data masking, audit logging, and role based access control. Hence, outcome and benefits. From a data quality perspective, there was a 98% improvement in data accuracy and consistency across all domains. There was a 40% reduction in time to insight, which automated reports and dashboards. It saved $1 billion dollars through supply chain optimization and demand planning. It had faster and more informed decision making using real time analytics. It achieved 100% compliance with GDPR, CCPA, and other regulatory framework. Over 50,000 staffs were trained in data literacy and using BI tool effectively. From a key success factor perspective, executive sponsorship and strategic alignment with business goals were achieved. Strong data culture promoted through training and communication was achieved. Use of modern data platform and best in the class technology stack helped in its productivity. Its integration of AI and machine learning for predictive analytics and anomaly detection helped in its success. Some of the lesson learned were data management must be business led, not IT only. Standardization and governance are essential for scaling the analytics. Cultural change is critical and everyone must see data as a shared asset. Continuous improvement and data literacy program sustain long-term success. In conclusion, the corporation success story in implementing good data management practices illustrates how structured governance, modern technology, and cultural transformation can derive measurable business outcome. Their approach serves as a model for other large enterprises striving to become truly data driven organizations. Let's now take a second case study. This is about an organization which is one of the largest financial institutions in US. It offers banking, mortgage, investment and consumer finance service. By 2016, it had over 70 million customers and a significant market share. Between 2011 and 2016, the organization was embroiled in a scandal where employees created millions of fake accounts without consent. The scandal exposed severe issues in data integrity, customer information governance, and ethical control. Root cause was due to pressure from unrealistic sales goal coupled with poor data oversight and lack of governance, leading employees to manipulate customer data and fabricate accounts to meet quotas. There was failure in data management, primarily lack of data governance, wherein no effective data ownership or stewardship for customer accounts, weak internal controls and audit mechanism to verify account legitimacy, data privacy was not enforced, customers were unaware that data was being misused. Next was poor data quality and integrity. Duplicate and fraudulent entries were not flagged by the systems. No reliable data lineage to trace who created accounts and for what purpose. Failure to match customer identity correctly led to multiple ghost accounts. The next was inadequate metadata and access control. In this, there was absence of metadata tracking, meant it was difficult to trace when and how the data was changed. Employees had excessive access rights to customer data, leading to their misuse. There was no separation of duty in data creation, validation, and audit process. From an ethical and cultural breakdown perspective, data management was manipulated to meet performance incentives. Employees were encouraged to game the system using data rather than report the problem. In summary, the area which were major concern was and the impact. From a financial penalty perspective, over $3 billion were in fine, legal cost and settlements, massive loss of customer and reputation to the damage. Reject last part. Impact and consequence. The result of this, there were fines of over $3 billion with legal cost and settlements, massive loss of customer trust, brand credibility was severely impacted. There were extensive internal audits and overhaul of the system and procedures, increased scrutiny by the Office of the Controller of Currency and other regulators. The CEO resigned, multiple senior executives were terminated, account closures and decline in the new account opening, resulting in customer loss. Lesson learned: poor data governance opens the door to fraud and unethical behavior. Lack of audit trails and metadata impairs accountability. Data quality must be continuously monitored for anomalies. Cultural pressure to meet metrics without checks leads to misuse of data. Regulatory compliance is insufficient if internal controls are ineffective. Data management must balance performance with ethics and transparency. What were the remediation action taken by the organization? The organization introduced centralized data governance teams, established risk and compliance unit with direct board level oversight, invested in advanced data lineage, monitoring and access control system, enforced segregation of duties and role based data access, rolled out mandatory training on data ethics and privacy, rebuilt customer consent framework and audit reporting. In conclusion, the organization scandal serves as a cautionary tale of bad data management, showing how poor practice in data governance, quality, and oversight can not only result in regulatory and financial damage but also erode organizational trust and ethics. It emphasizes that data is not just a technical asset, it is a matter of integrity, trust, and accountability. What are the penalties of poor data management across regulations? This is a snapshot. From a GDPR perspective, the penalties are up to 20 million or 4% of the global turnover. From CCPA perspective, it's about $2,500 per violation if it is unintentional. And if it is found to be intentional, it is about $7,500 for every violation. From a DPDP Act perspective, it's about 30 million USD per incident. From HIPAA perspective, it is about 1.5 million per violation per year. From SOX perspective, a fine up to 5 million, also having imprisonment up to 20 years for executives. From a PCI DSS perspective, it's about 5,000 to 100,000 per month plus loss of card processing privileges. From a Basel III perspective, regulatory sanctions is imminent, licensing risk, and so on. From mass TRM perspective, it includes penalties, naming and shaming, business restriction. From CERT E guidelines perspective, fines and suspensions of operation under Section 70B of IT Act. From ISO 27000, there is no direct fine but leads to loss of certification. And contracts are associated in many cases with certification, and that is going to take a hit. And of course, the reputational damage. Overall, there is reputational damage, business disruption, legal actions, revenue loss, and would trigger off a lot of compliance audit. In summary, bad data management can cost companies millions in fines, causing legal trouble, damage reputation, and even force businesses to shut down or lose their licenses. Let's now take a view on the products that or tools that can be used by professionals in data management space, and the management can also look at those investments. There are quite a few. You can pick and choose, you can see what works for you. Example, from data integration perspective, which is to extract, transform, and load data from multiple sources. You have tools like Informatica, Power Center, and so on. From a data warehousing, which is about central storage for structured data ready for reporting and analytics, you have Snowflakes, Teradata. You have something from Amazon, from Google, from Microsoft. From data lakes perspective, which is stores structured, semi-structured, and unstructured data at large scales, we have services from Amazon, Azure, Google, and many other. From an MDM perspective, which is to create a single consistent view of the key business data like customers or products, we have Informatica and so on. From a data governance perspective, which is about defining rules, roles, and responsibilities for managing data, we have tools like Data Galaxy, IBM Watson, Knowledge Catalog. From a metadata management perspective, which is about managing information about data, where it came from, what it means, we have tools like Apache, Colibra, Aleutian, and so on. You can pause the screen, take a screenshot, look at the product, see what is currently available, which is relevant to you, and you can experiment with it. Similarly, to extend it further, from a data quality perspective, which is about cleaning, validating, enriching, and monitoring, we have Trillium and other tools. From a data security and privacy perspective, which is securing the data access, usage, encryption, we have semantic data loss prevention, which is DLP, and others. From data lineage and observability perspective, which is about tracking how data moves and changes across system, we have Manta, Octopi, Datakin, and so on. From a business intelligence tool perspective, which is for analyzing and visualizing data for decision making, we have Tableau, Microsoft BI, Power BI. From data cataloging, which is about making data searchable and understandable across organization, we have Data World, Colibra, and others. From a cloud data platform perspective, which is full stack cloud data management, which is storage, processing, security, analytics, we have product lines from Google, Amazon, Microsoft, Snowflakes, Databricks, and etc. Hence, choosing the right tool depends on size and scale of your organization, type and variety of your data that you handle, regulatory and compliance needs, integration with existing systems, your budget, and the IT skills that you have. In conclusion, data is the cornerstone of digital transformation and a critical asset for every organization. Effective data management enables informed decision making, operational efficiency, regulatory compliance, and innovation. As data volumes and complexity grows, enterprise must invest in robust strategies, tools, and governance framework. With AI, cloud computing, and emerging architectures like data mesh, the future of data management is set to become more intelligent, decentralized, and business aligned. Success lies in building a data first culture, adapting best practices, and constantly evolving to harness the full potential of data. With this, we have come to the end of this video on data management. We covered foundation strategies and future trends and many other details. Do review. If you liked it, do subscribe. Comment if you have any specific points. Drop a note to me if you have any query or if you like any specific topics to be picked up. I would be happy to review and work on it. Closing this, thank you very much. Your time is much appreciated. This is your host, Savit Vittal Salian, thanking you. Namaskar.